Dr. Bhaskar, Assistant Professor, Department of Computer Science and Engineering, Anna University, Chennai. Area of specialization is software engineering and database system. Guided more than 12 research scholars, published more than 40 national and international papers. He is a reviewer and editorial board member in international journals.
Welcome to UGC lecture series in computer science. We are discussing about software engineering, and today's discussion it will be on software design. As an overall content, we will be looking at the introduction of software design. Then we will be looking at the comparison between a conceptual design and a technical design. We will be hinting on a term which is called modularity, which is very popular in terms of software design, and we will be explaining some of the properties that are cumbersome in terms of software design. What exactly is design required for? As we have seen, software requirements engineering, wherein we have captured the requirements from the end user and we are exactly to plot the requirements from the end user in terms of a very good design. So, the first point here more effectively required is this design has to be more creative than in terms of analysis. Whenever we are talking in terms of analysis, it is all in terms of words, a written content. So, those contents we are converting into a form of picture which will be legible and be clear to all the developers and the end users. So, this is software requirements are supposed to be the kind of agreement which we sign between a customer and a developer, whereas the design is a conversion of those textual format into a design format. Then it will be a problem solving activity. As I have already indicated, this design is to talk more about how. In fact, as I have already told, requirements engineering was to point on what of the system, whereas this particular design is to talk more about how we are supposed to implement on the system. So, when we talk about how of the system, from the how of the system we are to develop a software design document. In comparison with this requirements document which we have created already as part of requirements engineering, this requirements engineering it concentrated on what. So, what is the component that I am supposed to develop, and here I will be concentrating more on how it is to be developed. So, this particular picture indicates the overall software design process. Initially, we have a set of initial requirements which has been collected from the software requirements document which is called SRS. Then it will go for data on user requirements. We will analyze on the requirements. So, the topmost portion of these three blocks are to concentrate on the software requirement specification, from where we will validate the design against the requirements. So, this is one particular component which has to do a part of validation, whether this particular consideration of the requirement is on par with what the customers have given. So, that is called validation. On the other side, we have another requirement which is called obtain the answers to the requirements questions. Any specific question which a customer would have indicated, has that been incorporated as part of design, would have been given here. As a next stage, we will go for conceiving a high level design, which we are supposed to say it as an abstract diagram. We will hint with an example. Say for example, we will consider automating a result management procedure. If in case this result management system need to be automized, the basic things that we will collect for the automation process is something like the initial input in terms of student details, subject details and mark details, and after getting all these inputs, how exactly it is to be converted in form of a completed design. So, what we would expect out of the system is a result report. So as in case, this can be an high level abstract diagram. So that is what we have mentioned here. We are supposed to conceive a high level design diagram. Finally, we will refine and document the design, which makes it a completed design. So this particular stage of different process help in design framework. Now we will look at the overall design framework of a system, which includes a sequence of processes. It initially collects all the requirements, then gather data on user requirements and analyze the requirements based on data. When we look at the first three state of processes, it is a part of requirements engineering. So as we have collected the first three stages, it would indicate that we are done with the software requirements specification document. After that, we will go for validating the design against the requirements, and at the other stage where we obtain answers to the requirements question. So here we have to discriminate between two separate words, which is called verification and validation. Verification is something that we have rightly given, say any specific document that has to be verified on par with the database that has been given is called verification, whereas validation is part of the expectation of the customer, we say it as validation. So once we are done with the software requirements component, that has to be actually conceived for the design. So we have to validate on those sort of requirements in the beginning, and we will go for conceiving a high level design. Now let me talk something on this high level design aspect part, where the high level design is something very abstract. Say for example, we are to plot on a student result management system. If in case we are to draw a student result management system, here the actual components that we are supposed to conceive are the student details, staff details, mark details and subject details. Having given all these as the input, we will retrieve the result report. If suppose I am saying all these as words, this has actually to be picturized. So that is the main requirement of a design component. So we will convert all those that has been represented in words into a design level. So for which we will initially conceive it as a high level abstract diagram. So that is what I have given here. Conceive a high level design, then it comes to refine and document the design, that makes it a completed design. Actually is the overall design framework that we have established. As far as design is concerned, it has to satisfy these two level of people. One, it has to satisfy the customers, and it has at the same time satisfy the developers who are supposed to be the implementers of the system. Now we will look at how these conceptual and technical design typically vary. As far as designers are concerned, this design is a two-stage process, where one stage is typically concentrating on the conceptual design, which is to talk more of what of the system, whereas the point which I am talking about is how to develop it, which is how of the system, the technical design. The customers as the end users will typically concentrate on only what of the system. They will not bother how of the system and in what platform it has been implemented. Most of the technical end users would expect, only technical end users would expect on how it has been developed, whereas non-technical customers, mostly non-technical customers would prefer only on what has been developed. So what of the system to talk more on conceptual design, whereas how of the system is to concentrate on the technical design, who are supposed to be the system builders or implementers or the developer. Now we will ask a question something on who are the conceptual design people and what sort of questions they will have and what sort of answers we are supposed to provide as a conceptual designers. Question 1. Where will the data come from? What will happen to the data in the system? How will the system look to the users? what choice will be offered to the users, what is the timing of events, how will the report and screens look like. Say suppose I have given a sort of a mixture of 6 different questions. Let me give an example for all these 6 different questions in terms of the typical example which we are considering as a student result management system. Let us answer to the first question, where will the data come from? If suppose I am trying to automate a student result management system, the data that has to be fed in as student record needs to come in from a particular department. If it is to be on a particular subject, it has to come from the academic courses of a particular university. If it is about the staff members again will be from a particular department, and the marks that a student has obtained is from the result management department. So I am supposed to integrate these 4 together so as to bring out a sufficient content. So this will answer the first level of the question. The second question, what will happen to the data that is inside the system? If suppose I have some component of data which is available within the system, that also will be taken care of. Say for example, I have all the staff details, but then manual processing is no more required. So if I am to design a software for this type of application, for this application I will create separate login for individual staff members. If I am to create separate login for individual staff members, then their login ID, their staff name, designation and their corresponding password are all required. The initial input to the system as far as requirements detail will be the actual faculty name. What we are creating as part of design is individual unique faculty ID and their corresponding passwords. The third question which the system will answer is, how will the system look to the users? Is the system comfortable, easily understandable, easily manageable? User interfaces are properly designed. We are about to answer to all these questions in terms of conceptual design. Next would be, what choices will be offered to the users? Say we will take it from the faculty's perspective to the student's perspective. What sort of results would encourage the students from their perspective? Students having fed in their role ID alone would get back that particular semester's data, the pass or fail details of that particular semester, listed out all the subjects for that corresponding semester. So that can be very well easily adjusted, and which makes out to be what choices will be offered to the users. Fifth question is on, what is the timing of events when I am supposed to release all this. Say for example, if a corresponding paper need to be re-evaluated, that can happen only when the actual process of evaluation is over. So I will wait for that particular timing wherein the actual evaluation process is getting complete, then I will release the results. Only after that I am supposed to deliver the re-evaluation procedure. So this might require appropriate time which is already set for the system. The last question that I will ask for the system is, how will the reports and screens look like? My reports and screens should be comfortable enough which will accommodate all the requirements of the user. Say the report will be fetched in format of a printable format which need not be manual. All the records that I can retrieve out of the system will have to be exactly perfect and which satisfy all the needs of the customer. Say for example, a student who is expecting his results, by feeding in only the roll number, I can retrieve the student's name, the semester he has undergone, the subject that the various subjects that he has studied, and the department details can all be fetched, along with, if in case he is a credit based system, he can give the GPA for that particular semester. So these all records can be easily given in terms of a retrieving system. Now we will go for a short break. After the break, we will look at how it can be modularized. Welcome back after the break. Before the break, we were looking at the software design basic aspects to mention on how of the system, and we have continued it with the design framework. We have flown through the conceptual design process. Now we will look at the technical design stages, where developers are supposed to explain the hardware configuration, the software needs, the customer interfaces, the input output process of the system, the overall software architecture, the network architecture, any other thing that translates the requirements into a feasible solution to the customer problem. As you already might know, when we are about to prepare a documentation, we might have included hardware and software configuration of a particular system. Say if we are to develop a software, we might indicate to the customers what sort of minimum requirements are expected for a computer system. Say a minimum configuration of computer, what is expected. Say for example, the RAM capacity, the hard disk capacity, the speed of the processor, all these are the minimum expectations for which this software can run. So this is the fundamentals of the technical expectation. On top of it, specific to the software, we might have got some features. So after having done both the conceptual and the technical design, wherein in the conceptual design we have talked about only what, and in the technical design we have talked more of how of the system. Now we will convert it into an exact format of what is expected on a design. So by where when we make a design complete, design needs to be correct and complete, understandable both to the developers and to the customers, right at all level, and it should be maintainable. Most of the time we do this particular mistake. Any software that we would cover in or we have developed, we are developing perfect for that particular point in time, and after which if we are supposed to maintain it and we are asking them to redevelop it, which is not possible. Say if we have developed a software which has not been generic, which was specific, and it has got only few sort of requirements from the customer, after which I am trying to enhance on that particular part which the developers ask, it has to be developed right from the scratch. That is not possible. This software should be adjustable so that it has got its capacity to enhance also. Now we will look at another process of the complete design procedure, where initially taken the requirements procedure, we will start with an informal design outline, wherein we will put a generalized conceptual map, that is to indicate how exactly these requirements as a written statement or a document has been converted to a informal design template. We will make it an informal design, convert it to a more formal design and show the formal finished design to the customers, which is more appropriately acceptable, and this can be reiterated. That is why I have given a feedback loop for the entire stage. The transformation of an informal design to a detailed design, by where when I call it to be a detailed design, we will shift from the abstract level to a more detailed level, what sort of requirements is expected from the customers. Say as I was indicating, a student result management procedure has taken up only student details, subject details, mark details and the staff details. The output expected out of the system is supposed to be a result report. Now when we consider what exactly this result management system has to do so that it can convert all these inputs into a report, I may have to enhance on this report. That is, I am working in depth of what this result management has to do. Say I will go for the next level, which I will call it as level 1 or level 1 data flow diagram. In case of level 1 data flow diagram, I will take up individual components, say the student details, what sort of table is stored in the database so as to explain the level 1 of details. As far as staff details are concerned, what sort of details are expected from the staff for a particular subject. Likewise, I will proceed with each and every details in depth, which becomes a detailed design. So, for making this project work in a greater depth, we cannot assume the project as a wholesome work and we can continue. So, it has to be modularized, that is, it has to be made as sub-component, so that assembly of these sub-components would make out a complete component. So, now I define a component which is called modularity, which are given in terms of many different definitions, which is ranging from a Fortran. When I am using a Fortran language, it is called as a subroutine, whereas when I am using ADA package, I will use a word of package which is called as a module. When I am using procedures and functions, which has been used as modules in terms of Pascal and C programming. When I am using C++ and Java, I will call it in terms of classes, and the same Java I will be using it as packages. But as a overall, in terms of software engineering, I will define it as work assignment for an individual programmer. This work has to be carried out in a team. So, anything that has been initially given to a particular programmer and that programmer has to carry out only that sort of a job, his individual component may be called as a module, or 2-3 people putting together can do a sub component which is called a module, and let that sub component be modularized into sub components, which can also be called as a little module or a sub modules. So, all of the definitions that I have given in the previous slide are correct, and a module system consists of a well defined manageable units with well defined interfaces among these units. Say I have an interface that has been created, and let this be called a particular unit. Now, when I come across few faults on this particular unit, this has to be rectifiable, and when it is considered as a module, then only it will be rectifiable. Now, I will hint out with some of the properties that are very much required for software design. A first property of it should be a well defined subsystem need to be properly understood. A well defined purpose has to be provided, can be separately compiled and stored in a library. Module can use other modules. Modules should be easier to use than to build, simpler from outside than from inside. So, these are some of the properties which we should keep it in mind before modularizing the entire component of the work. Modularity is a single attribute of the software that allows a program to be intellectually manageable. Underline the word intellectually manageable. It enhances the design clarity, which in turn uses implementation, debugging, testing, documentation and maintenance of the software product. Whenever the modularity of a particular component is not properly designed, then it means it would impact, its impact would come across in part of implementation, in part of testing, in part of maintenance of the software, which are the sequence of process that are left with. So, once when we are correctly planning on how exactly it has to be modularized, then only you can start out with a complete design. This is a simple block which I have given, wherein I have compared between the cost of effort and the total number of modules. As the number of modules increases, as it would exponentially increase on the total cost of integration. Now that assume I have separate modules, if I am to integrate on these modules without any error, then it will be very difficult for me to get a complete product. So, do not modularize the entire work into too many sub modules, which would make the entire process literally not manageable. So, instead you make it that are worthier enough to integrate and into a transformed format. So, as the number of module increases, the cost of integration would obviously increase, and this indicates the minimum region of minimum cost, where the number of modules should strict within this limit, as the total cost of the software should not increase. The typical botheration when we are defining or completing a particular software is the cost, the time, the schedule for the overall completion of the project. Now we will look at the in-depth of the module. Here I will define you two different terms, one is called a coupling, the other one is called a cohesion. I will start with cohesion. Let us compare it with a brick. You consider a brick. This brick is evaluated in terms of its strength. Likewise, you compare it with a software component. When I have defined a particular software component, it is evaluated in terms of the strength of this particular component, whether it is manageable. That is why I have introduced a word which is called manageable, intellectually manageable in the previous slide. This software component is also to be manageable. And coupling in terms, when I am trying to construct a wall, I will be putting together two different bricks inside, between which I will be putting a cement paste. This cement paste would bind together two different bricks in a proper shape, and which will construct to be a wall which has a very good strength. Likewise, for a software component, I have a cohesive strength component. These cohesive strength components has to be coupled. There has to be a proper binding between these two cohesive strength components. So, two different terms have been defined. One is called coupling, the other one is called cohesion. Now, we will look at the summary of what we have seen in this particular session. We have initially started with what exactly design is about. So, design talked more of how of the system. Then we have flown through a sequence of processes which was given in design framework. Then as part of designers, we have distinguished between a conceptual design and a technical design, where as part of conceptual design we have given a high level abstract diagram, and part of technical design we have given a hardware software specifications, and we have defined on a term which is called modularity, in which we have started defining what coupling and cohesion mean. Now we will look at some of the questionnaires. What would design concentrate on? So this has to be something typically answered in terms of how or what, when, something like that. What are the requirements of technical design? Define the term modularity, and what is coupling and cohesion. Thank you.